Hi, this is our final project report for advanced quantitative methods for operations. Let me start by introducing our team. We are Ernesto Salmon, Juan Carlos Nava, and Isao Otake. Let me start by introducing our final project. This is one production area of the automotive manufacturer Bosch, and it has three main processes. The first process is called machining. And as you can see here in the diagram, there are four machining centers. Each one has two sets of fixtures, which allows the operator to load and unload parts in parallel while the machine is processing parts in the other fixture. The second main process is called deburring. And this process is done in an automatic machine where the operator loads the parts in one side of the machine and unloads the processed parts in the other side. And finally, we have the third process, that is quality inspection. Here it is. And it is done in a coordinate measuring machine. So this whole area was initially designed for three operators per shift, and it currently runs 3 shifts during the day. So the problem statement is that the management has been facing a decrease in demand, and in order to keep the competitiveness, the variable cost should be adjusted to the new volumes. So it has to be evaluated and forecasted the demand for the rest of the year, and see if it is possible to be the production to be covered in a 2-shift schedule. And in this case, if it's not possible, the measure should be made to minimize the effect of underutilization of the third shift.
So this is our actual or current state in flexing, in which we have the demand represented by a source with different queues, the machining process, the deburring process, and quality inspection. Each of one of these 3 processes has one operator working the 3 shifts. So we actually scheduled the current state with these shifts so that it can be actually analyzed in different scenarios to see if removing 1 shift could be beneficial or not. So here clearly are identified the 3 shifts. The red lines is the breakdown time, which is clearly identified since Sunday is a lost day for the operation. So we're going to run the model to see what happens. We are actually seeing the operators work within their actual processes, and in the end of this experiment, what we will see at first glance, it seems that all 3 processes are way too underutilized and could cover production in 2 shifts, since each of them individually does not exceed the 66%, and neither do the operators. However, this is not completely right if it is considered from the idle time perspective, which also takes into consideration machine breakdowns. The only one in which the idle time exceeds 33% is quality inspection. Therefore, we decided to schedule that particular operation in only 2 shifts, and we still had enough idle time of the machine and operator to reduce an additional shift. So we're going to move to the final experimentation. This is the final experimentation in which we are going to see that operator 3 will work only on the first shift. Okay. So if we run our model, we see what happens. Here it can be observed that operator 3 is still able to check all the batches producing during the 3 shifts of deburring. So the constraints in machining and deburring are the machines and not the operators. Each experiment was replicated 5 times and there was no significant difference in the observations. So our suggestion is to do the implementation by steps and evaluating the risks. We propose that quality inspection is reduced to 2 shifts for at least 1 week and see the results, since there might be collateral effects due to the simplification of the analysis. For example, the quality inspection is not the only task that this operator does. He does 5S, he does continuous improvement activities, and another of the risk is that in the current model, parts are being inspected as they are produced. This means that in our advanced scenario, any reaction plan will be contained in a smaller scale. It might happen that the problem started the day before and the risk of having a bigger quantity of not quality product is higher. So in the end, it's important to do experimentation to see what happens. This actually could bring approximately 18,000 annual US dollars of savings for the company, but still there are other things that need to be assessed. This was our final project. Thank you very much. Have a nice day.